Hello, this is our 8th grade Rube Goldberg project. So let me explain to you how it works. So to begin, the sound energy and the vibrations from the iWatch will allow it to flow down through the inclined plane to hit the ping pong ball box and knock over the set of dominoes, which will cause a ripple effect to knock over this middle domino here, which is connected to a string, if you can see it. It's connected all the way down to this domino, which will then knock over the marble to roll down this inclined plane and knock over the paper roll back to the funnel into the paper slide and knock over this set of dominoes, which is connected to a string up here, which will knock over this set of dominoes through this little contraption here, back to the dominoes, flowing through a car and then another car, which will knock over the domino to bring it down to this ramp, which is basically a seesaw. When this domino falls over, it'll hit the seesaw and flip this over. If you can see it, there are pins over here, which will knock over this balloon and blow it up. So let's begin. This is my energy cycle for my Rube Goldberg project. So to begin, the Apple Watch begins to vibrate and the sound, mechanical, and electrical energy allows the object to slide down the orange ramp. So the energies involved in this first step is sound to mechanical and electric to mechanical. The sound and electrical from the Apple Watch and the mechanical as it moves down the ramp. The next step is as the Apple Watch slides down the ramp, it meets the ping pong ball box and knocks it over. The energies involved in this step involves the mechanical watch. The watch is moving down the ramp, so it's mechanical energy or kinetic, and the ping pong ball box, when it hits it, it's also mechanical. So in the third step, the ping pong ball box falls down, causing the chain reaction of dominoes to fall over. So the energies in this are mechanical to mechanical. The box moves over and smashes the dominoes, and the dominoes create a ripple effect. And the dominoes hitting each other also count as mechanical to mechanical, which is another step. It's not another step, but it's another process. So in the fourth step, when the dominoes knock over its final companion, the last domino is connected to the long string, which is stretched to the domino that is waiting at the top of the table. The energies involved in this step is the mechanical, as the last domino is knocked over, and the gravitational energy, that is the domino on the top of the level surface. So in the next step, the domino is pulled forward by a string, and as the domino falls, it encounters a marble and pushes it down a large ramp. So the domino is on a level surface, which hence the gravitational potential energy, and it falls, which is the mechanical energy, and it also pushes the marble, which creates mechanical energy. In the sixth step, the marble, now moving, is moved through a cardboard roll, through a small funnel, and is turned and flowed through a mini paper slide. The energies involved in this step is the mechanical to mechanical to mechanical. The roll, and in all of these steps, it's still moving, so it remains mechanical throughout. In the next step, the seventh step, as the marble exits the slide, it hits another small set of dominoes, which topple over each other. This mechanical to mechanical to mechanical energy involves the marble, the domino, and the dominoes hitting each other, which is all moving, so hence the mechanical. In the eighth step, after the last domino is dropped, it is connected to a string, which is connected to another domino on the top of the raised surface. The mechanical energy, as it hits the last domino, is transformed to gravitational energy, which then begins the next cycle on the top of the leveled surface. The raised domino hits and begins another step of dominoes, which also begins a ripple effect. The gravitational potential energy from the top domino changes to mechanical energy as the raised domino falls, and then it topples over its other dominoes. In the 10th step, the last dominoes hit a ping pong ball that begins a small, fancy contraption. 3 ramps are laid vertically, with ping pong balls held in place by toothpicks at the end. As the first ping pong ball rolls, it hits the toothpick of the second ping pong ball, which then moves the second ping pong ball. The same process repeats with the final ping pong ball. So basically, once the first ping pong ball hits the toothpick moves out of the second ping pong ball's way, allowing it to move down. Same thing with the third ping pong ball. So the mechanical energy with the last domino changes to mechanical energy with the first ping pong ball, to the second ping pong ball, to the third ping pong ball. Then as the third ping pong ball hits a small domino set, it initiates the final sequence of this Rube Goldberg machine. The mechanical energy from the ping pong ball changes to mechanical energy from the domino, and then mechanical energy from the dominoes hitting each other. As the last domino falls, it tumbles over the edge and hits the cardboard seesaw with pins. So there's a cardboard seesaw, and as the gravitational energy from the domino at the top of the surface falls down, it lands on the ramp, which and in between those two steps there's mechanical energy because the domino is falling through the air. And there's potential energy when it falls on the seesaw, and sound energy because it lands with a small thud. And the final step involves the domino's weight, the one that fell on the seesaw, causing the seesaw to tip over. As it tips, the pins move with the cardboard. The pins eventually meet the balloon and end the machine with a pop. The potential energy is the domino on the seesaw, and the mechanical energy is the cardboard and pins that are moving, and the sound energy is the final pop. So that's my energy transformation chart for my Rube Goldberg machine. Are you actually kidding me? Shh. This never happened in real life. 3, 2, 1.